morning. In the last video lecture, we have seen problem number 1 of tutorial 3. Now we will move on to the problem number 2, where a charge distribution with spherical symmetry, the density has been given. This is volume charge density, and the volume charge density inside the sphere, it is this one, and outside the sphere we don't have any charge. So determine the electric field intensity everywhere. So what does that mean? That there is a sphere and this is a uniformly charged sphere, which means charge is distributed over the entire volume, and you want to determine the field in this region and also everywhere. So see, this is the volume charge density during this region. So which means that during this entire region you are having a charge, which means that it is a uniformly spread one. So this entire length is R1. So for 0 less than R is less than R1, you are having a charge, right? Outside you don't have any charge here. For R is greater than R1, there is no charge. But the field will exist. So how the field will be? See, the field will be existing from this point to any point up to infinity. But the difference is that when you are considering this particular point, I'll draw it again here. So if I consider this particular point P, so the field at point P will be due to the charge which is enclosed by this inner cylinder. So only this region charge, whatever it is enclosed, that will be creating the field at P. If I consider the point at here Q on the surface, then I am supposed to consider the entire charge. So entire charge will be creating an impact here. Let us suppose if I choose a point S here. So here also the entire charge will be the same. So what we infer from this is that as the point is varying between center to the surface of the cylinder, the electric field will be varying. And it depends upon, see, if I consider this particular point, it is not only the distance which will be varying, but also the amount of charge which will be varying. But if I consider this point, any point here, Q or S or something like this, here the charge is uniform because the charge is enclosed only here. The distance will be varying. So what you will be considering, you will be, so for 0 is less than R is less than R1, or both Q and R will be varying. Whereas for R is greater than R1, only R will be varying, while Q is constant. So we will take these two cases now and we will try to solve the problem. For the case number 1, where 0 is less than R is less than R1. So for that one, now case A, 0 is less than R is less than R1. See the field, this is the sphere. Now this is the center of O, and this is the uniform charge. So I am considering a point P here. I am considering a point P. So what is the charge enclosed by this point P at this point P? So I am supposed to consider only this particular volume of charge. Okay. So whatever the charge which is present by this sphere, spherical volume, which is at a distance of P from the origin, only this charge only I am supposed to consider. If I consider Q here, so I will be drawing a sphere around here like this. So whatever the charge which I will be getting here in this region, that I am supposed to consider. So it's not only the distance which will be varying in this region. So E is dependent on varying Q and varying R. Both will be varying here. So first of all, now what they have given us? They have given us rho V is equal to rho naught into R by R1. right? In this region of 0 to R1, right? This is what they have given. So first of all, let us try to determine the value of Q. So you know, when a volume charge density has been given for you, the formula is integral V rho V dV, right? Now since this is a spherical coordinate system, you know, dV, spherical coordinates dV is r square sine theta dr d phi and d theta. This is your spherical coordinates dV value. So that I will be replacing here, and rho v also I will be replacing. And the values, if you want to consider up to this region, so this region, let us suppose it is at a distance of r. Okay. So what I must consider, r value will be from 0 to r, whereas theta value will be from 0 to pi, and phi value will be varying from 0 to 2 pi, isn't it? So I'll consider it as r is varying from 0 to r, and theta will be varying from 0 to pi, and phi will be varying from 0 to 2 pi. Its value is rho naught r by r1 into r square sine theta dr d theta d phi. So what it will become? This will become r into r square. It will become r cube. So I can write it as r is equal to 0 to r, theta is equal to 0 to pi, phi is equal to 0 to 2 pi. It is rho naught r square, sorry, r cube, right? R cube by r1 sine theta dr d theta d phi. So first of all, I will do this with respect to phi. I will try to do this one. Okay, with respect to phi, if I want to do this one, see there is no phi component, so entire thing this will be treated as a constant. So what I will get as phi here. So Q is equal to integral of, I am just rearranging the terms. This is rho naught r cube by r1 sine theta. So first of all, I will do it with d phi, and next d theta, and next is dr. The choice is us. So first of all, I will be doing this one. So if you consider this one, there is nothing like phi here, so it will be entirely treated as constant. So what I will be getting? So I will be getting as r is equal to 0 to r. I will be getting theta is equal to 0 to pi. This entire thing will be treated as constant. So what I will be getting? I will be getting only theta, sorry, phi, and it must vary from 0 to 2 pi. Still there is d theta and still there is dr. So what is the value of this one? If I substitute first here 2 pi, I will get 2 pi minus 0. So I will get here 2 pi. So that 2 pi will be multiplied here. So what I will be getting here? Integral r is equal to 0 to r. Integral theta is equal to 0 to pi. This is rho naught r cube r1 sine theta into what I am getting? I am getting 2 pi, right? I will write the 2 pi here. Now again I am supposed to do with this value d theta, integration with theta. Here sine theta is present. So what I can do here? Integral r is equal to 0 to r. So the remaining terms I will remove it. 2 pi, I do have 2 pi here. So what is, this entire thing is constant. Only sine theta is to be integrated over theta. So for sine theta it is minus cos theta up to the value of 0 to pi. Still what is remaining? dr is remaining. So what is this value? If I substitute here pi, I will get minus of minus 1. It is 1 plus 1. It is 2, right? Cos theta minus cos theta over pi to 0, it is 2. So now what is my expression? R is equal to 0 to r, 2 pi rho naught r cube by r1. Here what I have got? I have got 2. So now what is my expression now? 4 pi rho naught integral r is equal to 0 to r 4 pi rho naught r cube by r1 dr. So in this one, if you carefully see, all these terms are, these are basically constant terms. So for r cube, the integration is r power 4 by 4, right? So r power 4 by 4 from r is equal to 0 to r. So if r is equal to 0, then it won't be having any value. So the final answer is, this is the final answer. So the final answer is q is equal to 4 pi rho naught by r1 into r power 4 by 4. So what we will be getting here, pi rho naught, 4 will get cancelled. This is r power 4 by r1. This is the charge. Now what you want in this, this is your entire sphere. Now this is O, this is your point P, right, which is at a distance of r. The entire radius is r1, which we have considered. So the charge enclosed by this sphere is, this is the charge enclosed, pi rho naught r power 4 by r1. Now applying Gauss law, I will try to apply Gauss law now. If I apply Gauss law now, if you carefully see, what is Gauss law? Basically, it says that integral of E dot ds is equal to q by epsilon, right? So this is Gauss law. Now this is normal component of electric field over the surface. See, the radial, the field will be in this direction. So whatever the area, normal area which is covered by this field, it is the entire surface area, right? What is the surface area of this sphere, which is having a radius of r? It is 4 pi r square by epsilon is there. So epsilon I have written. So what is E? 4 pi will get cancelled. So r square, here r power 4 is there. So it will get cancelled. So what I will get? Rho naught r square by 4 r1 epsilon. This is the magnitude of electric field intensity. If you want to write it as a vector, you know it will be varying from the radial direction. So I will directly write it as mu r because it is varying in radial direction only. So this is the equation for electric field intensity for 0 is less than r is less than r1. Now we will move on to the second region, where region number 2, where r is greater than r1. So in this region, so you are having an entire sphere. This is O, the radius is r1. So I am considering a point P which is at a distance which is greater than, so greater than r1. So this r is greater than r1. So even if you go somewhere here also, if you carefully see, what is varying? Distance is varying. Charge is fixed. The charge is fixed. So what is the charge which is enclosed by this cylinder, by this sphere? That we have already done. So if you want, I will do it again. Rho v is equal to rho naught into r by r1, right? So what is the charge which is enclosed by this sphere? We have already done in the previous slide, but let's have a quick look for the entire volume. Rho v dv. So what I will be getting? R must be varying from 0 to r1, entire r1 now, because I am considering the entire sphere now. And this is theta is from 0 to pi, phi is from 0 to 2 phi, rho naught r by r1 into, it is r square sine theta d theta d phi, right? This is the form. Now again, what I will be getting? I will be getting here, I will remove this, I will write it as r cube now. Okay, so now first what I will do, I will do it with I will do it with first phi, and next I will do it with theta, and next I will do it with r. So when I do it with phi, there is nothing pi here. So what I will be getting? I will be getting only just pi. 2 pi minus 0. So it will be right. So it is just a constant here when I do it with 5. So what I will be getting? I will be getting only 5, and its value will be varying from 0 to 2 pi. So the remaining two terms, they will remain here itself. So what is the answer of this one? The answer is here, it is 2 pi only. So I will write it here. So q is equal to integral r is equal to 0 to r1, and it is theta is 0 to pi, and its value is rho naught r cube by r1 sin theta into 2 pi. Still d theta is there, dr is there. Again, if I do it with d theta, sin theta, I will be getting minus cos theta, isn't it? So I will remove this one, I will do it directly. Rho naught r cube by r1, 2 pi I have written here. Okay. Now for this one, sin theta, what I will get? I will get minus cos theta, and it must vary from 0 to pi. Still dr is there. So what is this value? We have already done it, it is 2. So what I will be getting now? R is equal to 0 to r1, and its value is 2. So it is 4 pi rho naught r cube by r1 dr. So what I will be getting? So its value is 4 pi rho naught by r1 is constant here. So r cube will be varying from, so its integration is this one, and it must be varying from 0 to r1, right? So what I will be getting here? 4 pi rho naught by r1 into here r1 power 4 by 4 I will get minus 0. Okay. So what is the answer? If you carefully see, it is 4 pi rho naught r1 cube. See the difference between the earlier case and this case. So this is the charge now. Now having the charge, now if I again go back to my this is at a distance of r. So how to determine the applying Gauss law? Surface integral of normal component of is equal to q by epsilon. So here, what is a normal component? So I'll take as this one. So normal component is nothing but, so the field will be moving like this. So which area I am supposed to consider? I am supposed to consider this dotted region, right? It is also in the form of a sphere, but the radius of the sphere is r, right? So I'll write it as 4 pi r square into 1 by epsilon. What is q? That we have already done here in the previous slide itself. What is its value? 4 also goes, I think. It will be pi rho naught r1 cube, right? So it is pi rho naught r1 cube. See, what is the equation now? 1 by, pi rho naught r1 cube by 4 pi r square. Pi will go, I'll take it as generalized one. So rho naught r1 cube by 4 r square epsilon. So this is the field. If you want to write it as a vector, what I must do? 4 epsilon r square mu r naught. So this is the electric field when we are considering a point outside the sphere. So now combining these two, what I will be writing? For 0 is less than r is less than r1, what is the region? And for 0 is less than, r is greater than r1, what I will be getting? So for 0 is less than r1, what we have got? Its value is rho naught r square by 4 epsilon r1, right? Rho naught by 4 epsilon r1. What was this one? It was r square, right? Let me check once again. Yeah, rho naught r square by 4 r1 epsilon. Yeah. Now for the second case, we have already done it. Rho naught R1 cube, rho naught R1 cube by 4 epsilon R square. So this is the equation for electric field intensity everywhere due to a charge distribution with spherical symmetry given by this particular equation. Okay, that's it for this one. We will do the next problem in the next video lecture. Thank you.